Ready? Okay. Hello, everybody. I'm Miss Chakraborty, and
Miss
this is Miss
Magnuson.
Magnuson.
Hi.
Yeah, and we are going to give you a pre-lab of the Ideal Gas Law Lab. So all you need is a 1 liter soda bottle, and it is fitted with a cap that has a valve in it, so you could add air through it or let air out. We are also going to use a 10 milliliter syringe. Here we go. And we're going to start by making the volume inside the syringe 10 exactly. So right now I've got 10 milliliters of air inside the syringe, and I'm going to close the cap tightly so that I keep the amount of air inside the syringe a constant. No air is getting out or getting in. We're going to start by putting the syringe inside the bottle. And we are going to close the cap of the bottle. People see this? Okay. So what is the pressure inside the bottle right now? It is the same as atmospheric pressure, which let's imagine is 1.0 atm. It's very close to that. Okay, so
and
now
the syringe too.
Yeah, so the pressure inside the bottle is 1 atm. The pressure inside the syringe, therefore, is also 1 atm.
All right.
Okay, so now we're going to pressurize this bottle by adding more air to it using a pump.
It's going to be very loud.
It's going to be very loud. All right, so we're going to look carefully at what happened to the volume of air inside the syringe. As you remember, we started at 10 milliliters of air inside the syringe. Now it has gone down to about 3 milliliters. Okay, you may be able to read it more carefully in real time, but this looks about 3 milliliters. So why did the volume of air inside the syringe go down? Because we added more pressure inside the bottle by adding more particles or more moles of gas. So by looking at and it's a little warm, so that's something that we'll talk about when we do the lab. But so the idea is we can calculate what is the pressure of air inside the bottle by looking at the volume of air inside the syringe. So we started with 10 milliliters, and the pressure was 1 atm. While you watch this video, can you calculate what the pressure inside the bottle is if the volume has now gone down to 3 milliliters? That should be easy to do using the combined gas law. We're going to assume that the temperature remained constant and the amount of air inside the syringe is also a constant. It didn't get out. Okay, so now for your experiment, you are going to do this slowly. Each time you are going to collect a data point. You're going to release a small amount of air by pressing down on this needle. Okay, so I have now released a little bit of air from the bottle. So now there are fewer particles of air inside the bottle, so the pressure should go down. And now you can see, I don't know, can you see that the volume has now gone up to about 4? Yeah, 4. So now new pressure inside the bottle. You can calculate the pressure by looking at the volume of gas inside the syringe. And we are going to also mass this because the mass of this air, and we should have massed it at the beginning too, but we're going to mass this because the mass of air inside the bottle will help us calculate the number of moles of air inside the bottle. Okay, so each time you let some out, we're going to look at the volume of the syringe. We're going to mass the bottle. Okay, the volume of the syringe will give us the pressure inside the bottle, and the mass of the bottle will give us the number of moles of gas inside the bottle. And we're going to try to collect 10 data points. Is that it?
That's it.
All right, and then a bunch of calculations. Okay, good luck.